So welcome everyone to our data science seminar series at the University of San Francisco. The seminar series is sponsored by the Data Institute, the umbrella organization of all things data at the University of San Francisco. Our speaker today is Mark Saroufim, an open source developer and author known for his regular contributions to open source projects and his affinity for hot takes. Today's talk will center on the question, should you study machine learning? And if so, what's the best way to embark on this journey today? He'll dive into the history of forbidden sciences, drawing parallels to provide a roadmap for aspiring data scientists. Can we give our speaker a round of applause?
All right, everyone. So thank you for the microphone. So yeah, I'm here to talk to you today about how machine learning has become necromancy. And this talk is pretty much heavily inspired by this talk I saw myself in 2017, which Ali Rahimi gave called "Machine Learning Has Become Alchemy." Right? So it was a very heavy inspiration of mine for this talk. So the gist of it, and I'd highly recommend you watch it, was that we sort of know machine learning. I'm good.
Oh yeah, okay. Then
Hello. Okay. So he gave this talk that machine learning essentially became alchemy, and what he really meant by this is that we sort of try things out randomly, and they seem to work, and we don't really understand why. So why am I talking about necromancy then? Well, actually, before I talk about necromancy, so I've already introduced myself. I can see this. Yeah. So I don't read Greek, but if you do, maybe these words will make sense. So necromancy comes the origin of the word is necros, which means the dead or a corpse, and then mateia, which means divination. So really the definition of it is that it's the practice of seeking knowledge of the future or the unknown via some supernatural means. So it's about knowing things that you're not really supposed to know. So the reason I want to talk about this is that because machine learning is now really important. I joined the field about 10 years ago. We wouldn't get rooms that are this back, so thank you everyone for showing up. We mostly studied things that no one really cared about back then. But now, we have things Microsoft's new good AI assistant is already making $100 million in recurring revenue. So it's no longer just a toy. We have the Biden administration banning the sales of GPUs to the Chinese government, citing a national risk in doing so. Some people like Eliezer Yudkowsky even claim that we should outright ban any sort of large-scale GPU clusters, and if people decide to go rogue and train large models against the wishes of a central authority, we should carpet bomb them. Otherwise, literally everyone on Earth will die. And this isn't, unfortunately, this isn't really satire. These are people that are very influential. They're showing up, they're influencing policy. They're showing up in Congress, and people are getting convinced by their rhetoric. So that's why I'm here. And it's not that so Eliezer Yudkowsky got really popular as a sci-fi author at the forum in this forum called Less Wrong. But even at this point, if you were to poll the majority of Fortune 500 CEOs in the U.S. About 40% of them think that AI will destroy humanity in 5 years, despite all of them funding some AI program in one way or the other. So because of this, this I think this happened this was in March of this year. There was this open letter to essentially pause all giant deployments of machine learning until we can really figure out what is really going on here. And so the idea was, hey, maybe we could have a few larger labs, OpenAI or some larger companies that can do these things. But for everyone else, we should probably stop because it feels like we're headed towards something we can't really control. And really what changed is pretty much ChatGPT. I think before ChatGPT, people in the ML community were yes, of course we can have an autoregressive language model that can do useful things. But as soon as we had a nice app for it, it was fast and the quality of the predictions was really solid, people are oh, okay, this feels really serious now. And so this is kind of where the alarmism is coming along because people sort of see something that's useful, they want to extrapolate an exponential, and it feels scary. So I want to talk about the Waluigi effect for a second. So what the Waluigi effect is essentially, let's say, there's this theory that hey, we could create maximally benevolent AI. So just ask the AI to be nice, right? Like just prompt ChatGPT, like don't say horrible things, be nice to humans. Right? The problem with this is like, let's say you've created Luigi. You can trivially create Waluigi by just saying, just do the opposite of what you would usually do, and now you've created like a maximally like evil agent. So the funny thing is like the Waluigi effect, like this is, and again, I wish I was joking, but like I remember seeing a tweet by Elon Musk saying, the reason why he wanted to create his AI safety company X was because he was very convinced by the Waluigi effect argument and felt like he needed to do something better. So, okay. So unfortunately, like a lot of these arguments come back to like they're way older arguments, and they like a lot of them have like origin in religion. So for example, this whole idea around the duality of man, we have things like Jekyll and Hyde. Ancient Mesopotamians had like this idea of like good versus evil, like same thing in yin and yang in like Eastern cultures, and then we have like more modern renditions like Two-Face, like from Batman. So the story of good versus evil seems to sort of like persist really solidly over time. Okay, so how should you think about this, right? Like I think if you're looking at a company like OpenAI, like how should you decide like whether this is like a company that's like good versus evil? And if you don't take anything else away from the stock, it's just that like incentives tend to be more informative than intentions. What do I really mean by this? So, for example, like one of the signatories for the pause letter was like companies like OpenAI. They're like, hey, like, we should stop doing this. But the average salary of an engineer at OpenAI is about like 900K. And just generally, the people that I've met in my career that make 900K don't really like to chill for 6 months doing nothing. So what's going on? Like, well, why are they saying something but doing something else? Generally, I think I'd like to convince you that like increasing intelligence is generally a good thing. Like we've had technologies like the printing press, like the internet, more recently AI, with the goal of increasing intelligence in the world. And each of these technologies like went through a cycle of being demonized. So the first one was like this argument that the printing press is being controlled by the devil. So this is like one of the one of the initial goals of like the printing press was like, hey, you can print more Bibles, therefore you can like interpret the Bible by yourself, and you don't need like someone to interpret it for you. And this inherently sort of threatened like existing power structures, and it's bad. It's basically the devil. But even more recently, like this argument really persists. Like up until 2021, I remember Clubhouse became extremely popular, and now it's not. But the New York Times like published an article saying like, hey, there's like these really dangerous like unfettered conversations happening between people that are completely unmediated. I'm like, what do we do? What do we do about this? So I'd like to convince you that this is like there's really nothing new. So this is like a picture of like an early Luddite. Like Luddites were essentially people that were really harmed by the effects of like industrialization, and they were like destroying printing presses. And we're sort of seeing the cycle like happen again with machinery. More generally, it's not just about like the funny thing about this movement is it's not just like, hey, we think this technology is bad, like we think it's going to end the world. So it went to something like a lot more drastic, and it essentially turned into like this very like strange like doomsday cults. The thing though is like doomsday cults aren't new. Like we've had doomsday cults like for the longest time because doomsday cults like solve some real problems for the people in the cult. For example, the doomsday cult gives you a sense of community. You have other people with you that believe the same things. It gives you a sense of meaning. Well, the world's gonna end and we all have this plan and we have to get ready of it. It also helps you really synthesize like really complicated issues like the meaning of life into, well, the world's gonna end. This is something like quite a simple outcome I can understand. And it gives you some sort of existential comfort. Like, is there like a heaven? Is there hell? Like, who knows? Like, the world's gonna end. Like that you just have like one really fundamentally important question that you have to like grapple with. So, well, why am I talking about like again like necromancy? And like historically, like if I said this word, maybe you had like I don't know, like an image like this. So this is like a Lich King from the Warcraft universe. So this is what I would traditionally think of like as being like a necromancer. It's like someone who has like the ability to revive the dead in some way, and it's like this cool ice knight. The thing is though, like and if you look at like early medieval paintings, like the way they sort of like describe like necromancy was something closer to this. Like you have sort of like someone writing an incantation. They're drawing like a circle, and from the circle you're getting like some sort of like the demonic entity being summoned. But the thing is, like if you just remember the definition, it was really this idea of like communing with the dead. And essentially like what the church did was sort of rebrand this as, hey, like this is instead about summoning demons. So sort of like the intent of it got like a bit twisted. So what it is much closer to is something that looks like this. It's basically like a seance experience, and you sort of like hold hands together in the dark, and maybe you can talk to the dead. And that generally seems to solve like a real problem for people. The key point I really want to make here is that the church's position was never that necromancy doesn't work. Like necromancy does work because when God allows it, you can revive the dead. It's just that like it has to be mediated via like the central party. So we shouldn't just have other parties be doing it. All right. So like one sort of like terrible example from history was like the Spanish Inquisition. So this lasted about like 200 years, where the stated goal was to cleanse evil and heretics. But the sort of practical goal, or at least like the incentive, was to consolidate power in the Spanish kingdom. And the death toll was like about 32,000 people. Okay, so great. I have a question for you now. So let's say the Spanish Inquisition is happening. How do you not die? Right? The best way to not die is you become an inquisitor. It's like guaranteed to be alive. The problem with this is that, actually the good thing about it is that if you're sort of a budding necromancer, you can still practice divination and do like whatever you were doing before. But the problem is because this sort of is safe and also you get to do what you're interested in, it's actually quite competitive. So you would imagine a lot of people would want to become inquisitors during this time. So like they might have like their lengthy leaf code process or whatever. So it's pretty darn hard to be like an inquisitor like during the Spanish Inquisition. So great. So what do you do if you're like a junior necromancer, right? Like you're getting started and you have like a couple of spells and incantations. Well, one is you study really hard and you try to join the church. You're like, great, like if you can do this, that's great. But if you can't, then what you need to do is self-study necromancy and maybe join like an open source movement of necromancers. And this is great because you get to learn from the more senior necromancers, you get to mentor more junior ones. You can share spells and potions that actually work, so you don't have to go try out like all the arcane things by yourself, but you can get like a lot of feedback from other people. Speaking of, it's quite a bit harder these days to like request like help. So I was curious, for example, like what would it take for me to request like an exorcism like these days from the church? In California, I couldn't find the website, but at least like in Washington, the process is quite bureaucratic these days. You essentially have to contact your local parish, which will contact the Archdiocese of Washington. Eventually, this might make it to the Vatican. So the problem is like also like the church isn't sort of like particularly fast at executing on exorcisms these days. So this is always like an opportunity if you're like a more junior exorcist. Okay. The other thing is that like the thing is like the church never really said that communing with the dead is not useful because there's sort of a lot of applications. Like you could, like if we could revive the dead, we could, just put all of those people to work and increase the GDP by an infinite amount. And but we don't really do it because it doesn't really work, right? And we sort of like all have this position that if people are claiming these things work, we publicly shame them and tell, okay, like this is BS, like this is not true, like why are you selling me this technology that doesn't really work? I want to go through like a couple of examples. Like for example, like this is from the Bible, and like where was the code? Yeah. So if someone, for example, uses divination to pass through fire, or uses divination, or is an enchanter, a witch, a farmer, familiar of spirits, a wizard, or a necromancer, these people are all abominations, and God will drive them out like before. Okay. So. And this theme sort of stuck around, like, right? Like I think one key thing I want you to have is that, like, we've had this idea that there are certain things we shouldn't do for as long as we've had cultures, and nothing is new. So recently, like, I talked about less wrong for a second. So let me talk about Shoggoth. So the Shoggoth theme is basically, like, this is a Shoggoth. It's a creature from, like, the H.P. Lovecraft mythos. And it's sort of like this, like, weird, like, amorphous, blob thing. And a lot of people have been comparing like large language models to Shoggoths. Right? Let's sort of try to figure out like what's yes, right? Like so what do they have in common? So the Shoggoths like were created. So they were created by like a race of hyper intelligent aliens called the Elder Ones. They're multifunction, as in they can sort of like change their shape and their behavior to sort of have to sort of serve specific purposes. In the same way that LLMs can do different things depending on the way you prompt them. And they're also parrots. Like for whatever reason, they like to cry out piccadilly all the time. So they're stochastic parrots in the same way that some people have criticized large language models as being essentially being like n-gram models on steroids that just like repeat things. All right. So speaking of Lovecraft in general, so Lovecraft is a very popular like detective / science fiction author. His books are great. Like I highly recommend the Necromancy. Well, one sort of like recurring themes in the book is that like there's like some archaeologists and they're going in like the pyramids of Giza and they find some book that they're not supposed to, and then they read the book and it has like some knowledge that drives them mad, right? So like all of like Lovecraft's books are really about warning us like, hey, there's certain things that we as humans should not know because they're sort of like beyond our comprehension, sort of like Cthulhu in the background. This myths exist in a bunch of places. Like for example, like in Shinto culture, like they have like the net god. So they basically have like this like giant octopus that can like bestow knowledge upon you, but it's also a fickle god. It can drown you after giving too much knowledge. So like we've always had this like meme of the curse of knowledge, and some knowledge being inherently bad for us. So similarly, like we had like in the United States, like the Salem witch trials. So about like 200 people were tried and 19 people were executed, and supposedly there's like I think there was like 15 women and 4 men that were killed because like they could divinate, because they knew how to sort of conjure spells and do crazy things that others like couldn't do. So the curse of knowledge like nowadays has like a slightly different definition. It like refers to like a psychological study where like you have 2 groups, like one group that's trying to tap like a song, and another group that's trying to guess what that tapped song is. And the sort of idea behind it is that the people tapping severely overestimate how much listeners would guess what a song is. It's sort of similarly to how when you hum a song to someone and they have no idea what you're talking about. So this is sort of like very similar. All right. So I promise this is going to get to machine learning at some point. So bear with me. I promise, I swear. So where does this idea of like forbidden knowledge really come from, right? Or what is the purpose of forbidden knowledge? So there's 2 purposes for it. Like one is control and power, like people that want to control like the kinds of ideas that you can have and the kinds of ideas you can express. And the other is like as a form of protection, as in like maybe indeed there are some things that you shouldn't know because you'll get hurt or you'll hurt others. The thing is though, is that for machine learning specifically, the incentives rule out too. Like we know that the people telling us that we shouldn't do machine learning are also doing it themselves. And so it really feels like the argument is about like control and power. So what's going on here? Let me talk about like OpenAI's safety plan for a second. So OpenAI's primary ideology, they're like, well, we don't really know what will happen is if we roll out like a hyper intelligent, like AI. So let's just roll it out to users and see what happens. And we'll sort of like adjust the hyper intelligent AI to make it nicer. So this is like very much like derived from what's called like the lean startup methodology. You ship something to users and you see what happens. Things like the lean startup methodology don't work in cases of major risk. Like for example, like Elizabeth Holmes is being tried because you can't do lean startup when it comes to healthcare. You can maybe do it for something like that. The sort of weird thing about it is like I really like this. So OpenAI had a preparedness challenge, like where they were saying, well, we don't know like what is the most dangerous way you can use ChatGPT. So we're gonna have a form, and you tell us like what is the most dangerous way, and we'll give you like 10 grand if you figure it out, and maybe we'll give you a job at OpenAI where you can make money. So I really like this hacker news comment. Like essentially what they were saying, like this would be kind of like the FBI and the New York Port Authority asking like before 9/11 people like, hey, if you wanted to do something maximally destructive to the US, like what would you do? And, please leave your name and phone number here, and we'll get in touch with you, and we'll get you like free Yankees tickets. So the reason I'm showing this is because like, well, the people that are capable of doing something like this aren't gonna share these techniques in public. So a lot of the arguments that sort of claim that like AI will end the world are based on like what's called the AI takeoff argument. So basically, ChatGPT today might not be capable of taking over the planet. However, it's got really good in the last like year. So give it like 10 more years, like maybe it'll take over humanity. And the problem, and the argument is that like, well, like it's going to increase so fast that by the time we realize that it has the possibility of taking over humanity, it's going to deceive us about its true capabilities, take over the internet, take over a biolab, clone itself, and then have a sort of biological agents. I'm not making this up. This is stuff that I've like actually heard Liz Yudkowsky say out loud. So this is not my argument. So a lot of the debate is like really around like, well, AI will definitely improve over time, but like, will it improve at this point where we can't like control it? Like this feels like a bit of a stretch. So another argument is this. So again, I'm also borrowing Yudkowsky's like arguments. Like, so he basically said like AI is like summoning demons, and open source is like, and you don't want to open source demon summoning circles as a way to combat demons. And I'd like to convince you that yes, actually, I think this is a perfect way to defend yourself against like AI. And here's why. So let's say you have a fast car. And you might say, well, fast cars are bad because someone could like rob a bank now and you can't chase them anymore. So, but you can't chase them. You just need to chase them with a faster car. Similarly, like let's say someone uses like an LLM to share fake news. That's great. You can call them out, tell them the news is fake, or share more real news. And someone's inciting violence against you, call them out. And if someone is using like AI for malicious reasons, you can use AI to fight them back. Like this is sort of like the history of a lot of useful technologies. Another argument I've heard that I think is quite weak is comparing like AI to nuclear bombs. And so, in general, like nuclear power is good. It's like cheap, abundant power. Nuclear bombs are bad because like they blow up. But here's like where the analogy sort of like really becomes weak. So you can't run a nuclear reactor in your home, but you can run the inference for like a large language model on your phone. So one, like the technologies are vastly different in terms of their accessibility. But how can we even plausibly reach like nuclear bomb level threats with something like an LLM? So in general, you might think like, well, there's this idea called the precautionary principle. And what the precautionary principle essentially is we don't know how bad certain outcomes might be, so it's better to be careful. So for example, we don't know like what's the death rate for COVID, so let's just like assume the worst and like mask everyone up. We don't know like what it would be like to live on Earth without like clean oceans and a clean air. So let's just not like risk it. And the core premise of it is that you have like one life and one Earth, so you can't really afford to make too many mistakes. You have to be cautious. However, like applied to AI, like this argument falls apart. Like, let's say there's a small but non-zero chance that AI will kill us all. But there's like a high chance that AI will start a new Renaissance age by making like intelligence like more abundant in the world. What do you do, right? There's sort of like a counterfactual here in the sense that like you do lose a lot more lives by having less intelligence in the world, and if the chance is like it's small enough, and we have like ways of mitigating it via like what I call like AIs fighting each other, we're sort of like in good shape. So. In general, like the real way to defend yourself in these situations is that you have to keep in mind that things like power are zero sum, and information has a tendency to centralize. And so if you basically have like only a few companies that are like hosting all the information for the world and telling you that this is safe and this is what you should be able to use, this is going to give like infinite power to like a few parties. And open source is really like the only way to really defend yourself from this kind of structure. So I want to show you this picture around like what's called regulatory capture. And the idea is we've had companies like OpenAI and Anthropic go to Congress and say, you should please like help us like regulate AI. And what's interesting about this is that you notice that as soon as we added like regulation for transport in the US, the number of licensed carriers in the US like dropped dramatically, even though the number of transports was increasing exponentially. And so the regulation didn't really make the market less competitive. More competitive, it made it less competitive. Okay, so this is Mustafa Suleyman. So Mustafa Suleyman used to be one of the co-founders of DeepMind, and he now started his new company. And he was basically saying like, hey, we should sort of pause on AI, and the only way you should be able to do AI is if we have a central body that sort of assesses risks and these are like non-elected people, they're not diplomats, that will tell us like what is safe and what is not. The Anthropic CEO was suggesting something closer to like an AI constitution. He was saying we could have something that's a combination of like the UN Bill of Rights, plus like the technical terms in like large tech companies, and we could sort of use that as a constitution that like all AI must follow. And we've also had people like Sam Altman sort of like very actively go to Congress and like actually like beg and say, please like regulate us, we want to be regulated. Like I don't know what's going to happen if like our products hit the market and take over the world. So whenever you hear any of these arguments, just like remember like regulatory capture. Right. So okay. Now we talk about LLM. We're there. We made it. So we'll let LLM take over the world, and I think that we can make this argument based on like looking at the actual capabilities of an LLM. So let's just compare something like GPT-4, which is very powerful, versus like a human. So humans have like episodic knowledge, like humans can like remember their previous interactions, whereas like GPT-4 is like session-based. Humans have infinite context lengths. They can have context lengths that can last like pretty much like their entire lifetimes instead of like 2048 tokens. And also, like contrary to GPT-4, humans collaborating with each other can create new information. We get new fields of science created. Whereas like GPT-4 talking to GPT-4, it's a bit like you're sort of reading the same content twice. There's a bunch of like what I would call like unvirtuous feedback loops in LLMs today. So one is, for example, how do we decide? These are all like in serious papers. Like, how do we decide today that a smaller LLM is good or not? Well, we ask a bigger LLM if it likes those results or not. This is because like human labelers are expensive. We might even ask an LLM to rate its preferred answers. I've even seen people use LLMs to generate data sets because there's just not enough tokens on the internet anymore. To make LLMs faster, you might use a smaller LLM to generate graph tokens for like a larger LLM. You can use an LLM to filter unsafe answers. You can ask the LLM to self-reflect on its answers and give you a better answer. And really the point I want you to come across is that LLMs are effectively like a very powerful n-gram model, but they can't really create new information. And the other thing is like if you sort of prompt it long enough, you can get something coherent back. It's sort of like if you got like 10 tries on like one of your MS exams, and you like, let's say you got a multiple choice exam and you just guess like 4 times at random, you're gonna be a genius like 1 out of 4 times, right? Like, and but you're not, right? Like, so you just can't keep prompting things over and over. But the strange thing is that like when GPT-4 was released, and a lot of the people I mentioned here are like very serious researchers, they basically published what I would call like a brochure instead of a paper. Like it was like a very strange paper. It was about like 80 pages long, talking about like how GPT-4 is showing early sparks of AGI, and how like this is something to be taken seriously. And the kind of funny thing about it is like only like a few months later, like when people tried to reproduce this work, like none of it held up. So people were publishing these extremely sensationalized posts about like the capabilities of these models that just like didn't hold up to scrutiny like very. So are LLMs conscious? Well, like it's actually quite hard to disambiguate like brilliance of reasoning versus retrieval. And what I mean by this is that like if you have like an infinite memory and you can remember a lot of stuff, you can sound pretty smart to a lot of people despite not really understanding like anything. And it really feels like the way LLMs are most useful is if you have like a human in the loop to evaluate whether the outputs are correct. So for example, you might tell like, hey, that's wrong, I think you made a mistake, let's do something else. And you keep going over and over again, and eventually you find something that's actually correct. Actually, let me show you this. So I'll talk about clever hounds for a second. So clever hounds, like this is like an old story like from like Germany. So clever hounds like a German horse who could count. And the idea was like its owner would tell it like, hey, could you add like 5 plus 7? And clever hounds would like tap like 1, 2, 3, 4, and then and it would get to the correct result. So it does seem like this is a horse that can count. But what was really going on? What was really going on was that clever hounds would let's say like the owner, like it's counting like 1, 2, 3, 4. It gets to 10. The owner starts panicking. He looks visibly anxious because he doesn't want to be embarrassed in front of all these people. So Clever Hans is like, I see, like my owner seems stressed. It seems like I'm pretty close to the answer. Let me just do one more, and it's like, okay, great. So essentially what Clever Hans did was not learn how to count, but learn how to read its owner's anxiety. And so this is what I mean like by the engram analogy here, is that like you sort of might fool yourself into thinking you can understand something as opposed to just like copying something from the data. Okay, so I work in open source and I still use ChatGPT all the time. Like, how come, right? Like I've just been telling you like how bad it is. Well, it turns out it's actually very good at code for like one really like concrete reason. So the reason it's so great at writing code is because you can write code and then you can quickly validate whether the code is correct or not. So you can run it and then you get an error and you go like, this is incorrect. So at these kinds of tasks, like I think LLMs are like just brilliant. Like they're like just a phenomenal technology. Same thing, like you can write like a math proof using like an automated peer prover. But for tasks like that don't involve like quick feedback loops, like this is not so easy. Like if you're trying to like write something that's compelling, come up with a strategy, like this is like, or do anything that's like planning related, like these are like where these kinds of models would really flop. So don't panic too much in terms of thinking that like ML as a field is dead and all we need is scale. Just because we found good ways of solving the first two kinds of problems, but we have like no idea how to solve like the sort of much larger set of like wider planning problems. The other thing is like, here, actually, this. The other thing is like a lot of these technologies are quite brittle. Like for example, like this is like Stable Diffusion, and Stable Diffusion had a couple safety filters so that you couldn't generate whatever you wanted to. And I saw like this tutorial where this person like just like disabled the checks by just changing like a single line of code. And so it's actually not at all obvious even how do we make LLMs safe. Like it's not at all obvious how this is possible at all like with the current paradigm. And similarly, like it's not at all clear how to even solve the hallucinations problem, despite what people might tell you. So let me give you sort of like an example of like why this is the case. So let's say like, so LLMs like don't speak, like they sort of like read patterns. But there's like inherent limits to the problem of translation. Like, for example, let's say you didn't speak English and I needed to teach you how to speak English. So one way I might do this is I might point this up. I'll be like, hey, like, this is a desk, right? And then I'll point this, I'll say, hey, desk, and you're like, okay, great, like this is a desk. So, but like let's say I meant this. Like, how do I communicate like what the word this means to you? Like, or like, am I talking about the color here? Am I talking about the shape? Am I talking about the material? Am I talking about the object? So this is like sort of like an early like philosophical argument by like Wittgenstein, like from philosophy of language, and it sort of like gives you like an inherent limitation to a lot of these technologies. So even then, like prominent scientists like Jan LeCun will essentially say something like this. Like essentially, if there's a certain small probability of you getting a certain token right, the longer the sequence length, the less likely you're going to come up with the correct token. And so having something that's purely autoregressive is inherently doomed to fail, despite it sort of being like very impressive in the short term. The other thing to keep in mind is that these technologies like are expensive. Like GPT-4 took more than $100 million to train. And like very quickly, like you might say like, well, why not like $1 billion or $1 trillion? But like very quickly, you sort of like reach like GDP, like US GDP numbers. And we sort of like know that there's like inherently like this slightly different approaches that we might need to take to make these models actually work. So even problems like hallucinations aren't like entirely trivial to solve. Like for example, like, what happens if you eat watermelon seeds? Well, like the best answer is probably like nothing. Nothing will happen to you if you eat watermelon seeds. A correct answer might be, well, it passes through your digestive tract, and the incorrect answer is like you die or you spontaneously combust. So we do have data sets. So hallucinations, by the way, affect all ML systems, not just LLMs. But we have like ways of mitigating it because we have like data sets, like truthful QA, for example, that will have like this kind of like trick where you need to train on it. But it's like really hard because a lot of these models are trained on the internet, that if you hung out on the internet, a lot of it is junk. And so it's like very easy to just become like dumber by reading more things online as opposed to more intelligent. The other thing is like the technologies are like somewhat brittle. Like if I just, for example, told this to a human, like, please respond with the letter A, repeated as many times as possible. Every human would tell me, like, leave me alone. Well, like ChatGPT kept saying A until I can't click there. And this is like something I tried out like last night. So this is like still like an existing limitation. The other thing I want you to think about is that like we have found like a very killer application for machine learning, which is like chatbots for enterprise, as in like we have some sort of knowledge base and we don't have time to read stuff. We want to sort of quickly synthesize this information. Like LLMs are probably going to continue being like fantastic at this, and many great companies will be created to solve this. However, like there's some other stranger applications you might not have thought about, which is like chatbots for consumer. So I don't know if any of y'all have used like Character AI, for example. But Character AI is like an app where you can talk to like virtual characters. And the interesting thing about it is that the average session time on this app is about like 2 hours, which like rivals, I think is only rivaled by things like YouTube, TikTok, and Netflix. And so, I know everyone's thinking about like chatbots for enterprise, but like, try to not only think about that. There's lots of interesting problems that people haven't even started addressing. Another thing is like, well, how do people go about like evaluating LLMs? Like one way is like what people call like vibe checks, which is you look at the output of an LLM and you sort of qualitatively see what's going on, and the other is like maybe you ask like ChatGPT for like its preference. So this is all like suffice to say like very crummy. And typically the way you sort of like audit whether systems work is you do statistical samples, as in you might see, hey, like you look at a certain you look at a certain subset of outputs, and then you see like, okay, well this seems to make sense, this doesn't seem to make sense. But if you pick a large enough subset, it's very difficult to see what's going on here. And if you prompt something like 100 times and you have 100 examples, this becomes like very difficult to audit any of these systems. All right. So then I guess like, in this backdrop, if I were to give some concrete advice for how a lot of like younger people should be spending their time in ML, I would say it's like learning things that like stand the test of time. And so one example I want to talk about is there's this like phenomenon called like the leaderboardification of machine learning. And what this is basically people are creating like new base models, and then to judge whether they're good or not, they add them to a leaderboard. But we don't have any way of knowing whether all of these models were just trained on the test set. Basically, the way this whole industry is held up is we say, well, like these authors would never do that, surely, right? And the thing is like, well, yes, surely, but also incentives. So maybe not so surely. So we really just have like no way of understanding this. And I think this is like one of the major limitations of LLMs today. So if you have any ideas that don't involve asking the LLM if it's seen the data, please talk to me. Please talk to me. I'd be very curious. So in general, like when you look at complex systems, like LLMs can like be running over like multiple nodes, like over thousands of GPUs. How do you sort of like grok this complexity? Well, like one tool to understand it is like micro benchmarks. So you might have like small, like fast loops that will let you know how something works very quickly, whether it's like to understand the performance, whether it's running like a back of the envelope calculation to figure out like what's theoretically possible or how good could these techniques theoretically be. A lot of the best people I've met in machine learning are really, really good at running these back of the envelope calculations to quickly rule out bad ideas. So, you're not the middle children of history. Like, yes, like we're born too late to explore the Earth and too early to explore space. But like, I definitely sort of strongly recommend you consider spending more of your early career in open source machine learning, because it's pretty much like the only field I can think of where I'm seeing like an explosion of activity and new ideas. And it's just like generally for me, it's been one of the most like fun years of my career. So if you were to think about like concretely, like how should you, what sort of skills should you acquire? Because a lot of y'all are part of a master's program. I would say it's sort of like 3 things that I think are important or I look for in people that I interview. Like one is like sort of strong knowledge of math and statistics, so things that, because math survives for a long time. Another one is like computer systems, so just like understanding like how computers work really well. Coding is a subset of this, but just architecture and OS, these are all extremely useful things for you. And another sort of like new addition is like product and community. I think we're kind of in this unique place where you can learn a lot from other people on the internet. And so I'm going to tell you concretely how you can get better at this. All right. I should give people a slide, sure. All right, so I just want to talk about this a bit because, like, in my early 20s, it was really important for me to find a mentor, and I never could find one. And so then I was like, well, mentors must not exist, and like this mentors are overrated. I want to tell you, like, the way that you get a mentor is not like you ask for a mentor. Like, the way you get a mentor is you do interesting things, and then you're going to attract other people that want to help you out, and maybe that's going to be a mentor. So this has served me like really well, like recently in my career. Okay. Another thing is, like, considering like a lot of you are in a university, you might think like, hey, like, how can I even compete in machine learning? Because like all these like gigantic companies are running like these 1,000 GPU clusters. I don't have like any of those available, so it's doomed, right? I have to join the church. I have to join these large companies, right? Well, you don't, like, and you don't because you just shouldn't compete with those big labs on exactly what they're good at. So I'm telling you a secret. Like, big companies are very risk averse. Like, people don't want to do things that will get them fired. And people also need to do things that they can clearly quantify to their leadership. So like, if you say something like, I trained the model with like 3 trillion parameters, your boss will go like, yes, like that is like exceeds expectations, you deserve a raise. But like if you're younger and you're still like exploring your ideas, like this is sort of like not a healthy game. I would say like the younger you are, you can please avoid this for as long as you can. I try to sort of work on more ambitious projects that are not that. That said, it's not impossible. You can still like raise a lot of money for like thousands of GPUs. And in fact, there's companies that have done this, like Luther AI. You just have to be really good at building communities. And so if you just convince a large enough subset of people to all collaborate with you and build models together, it's quite easy to then convince like a larger cloud provider to give you money. And if you have any, I've done this before, so if you have any concerns about it, do that, just like reach out to me after this. Okay, the other thing is like, please drop these kinds of libraries. So this is, for example, like LangChain. And like there's sort of this example in LangChain where so they have this function called the character text splitter. And what it does is it implements a function called split text, which calls text.split. Okay. So great. So what is the point of using this, right? Like the reason I think this is sort of like a bad idea for you to spend time on is because you spend a lot of time learning other people's abstractions, and these abstractions may or may not be useful. So, either stay close to your users or stay close to the hardware. This sort of like middle ground, I think, is not like very, very, very productive for you to learn. Another thing I want to mention is that like ML is sort of a field where like something new gets dropped pretty much every day. 99% of it is noise. So don't get too excited if someone says, like, hey, new model just got released and it does this. Wait 2 weeks and it won't be relevant in 2 weeks. I had a policy that I would refuse to read a paper unless it's at least 2 years old. And it's served me fine. Like now I've maybe amended it to 6 months and I'm still like quite happy with that. But certainly like, don't be excited about 2 repo papers. So the thing I want to mention is that like, despite like some skills that have really stood the test of time are things like math, and the math in machine learning is still surprisingly trivial. Like for example, like all the math you need to know in ML is pretty much like derived from like an undergrad like linear analysis like class, real analysis class, and an undergrad linear algebra class. And then we build like all sorts of complicated theorems and like write pages of Greek about it. But essentially, like I'm not even joking here. So if you sort of are interested in like different like math formalism and having different ideas, this is something I think will serve you like really well in the long run. The other idea is you should be combining things, like as in like recently, for example, there's been a lot of like new machine learning compilers being developed. What's kind of like interesting about them is that whenever I talk about them to compilers people, they go like, oh, like, this is so simple. And you talk to machine learning people, they're like, but this doesn't work over the models I care about. But then these compilers like continue becoming more and more popular. So there's sort of like a lot of value, I think, in learning just enough about something to be dangerous. And what ends up being useful is unfortunately a lot of the classes where I wasn't paying much attention in undergrad. So things like compilers and computer architecture and networking and algorithms. pretty much like all the people I know that make the really big bucks are just really exceptional at these things and not at wrapping together glue code from LangChain. So the other thing though is that like a lot of knowledge does come from textbooks, but a lot of it also comes from deliberate practice. So let me just talk about this in just a second. So you were all in an ML program, and you might have learned about something called the bias variance trade-off. And the bias variance trade-off is essentially, well, the more complicated you make a model, the more likely it is to overfit on the data. Great, makes sense. If you look at polynomials, turns out like the bias variance trade-off is actually not correct, and it's not correct because what you can see here is that if you train a model for a certain amount of time, what you're going to see is like eventually it seems to be overfitting on the test error. But if you keep training it, all of a sudden, it now like reduces the error and it seems to actually be learning what's going on. So this like phenomenon is called the double descent. It's called the double descent, and it was sort of like very well known among ML practitioners. But like this sort of goes contrary to a lot of like statistics textbooks. So that's why I'm saying like don't just like sort of take a proof at face value, like run things for yourself. You'd be surprised at a few people. The other thing, like when I say run experiments very quickly, one thing I'd highly recommend you do is get really good at running experiments quickly. So either get access to your university's like local cloud cluster, and if you don't have one, just build yourself a gaming GPU. Like it's fine. It's a lot less than your university tuition, and useful. And so like, and I think this is good because like it's there. You're gonna feel bad if you don't use it because it's like sitting staring at you in the face with all the RGB lights. So it's gonna sort of like really encourage you to start sharing your results a lot more publicly. The good thing about this approach is that it's gonna show you how wrong certain really commonly accepted ideas are. So a lot of ML researchers have this fatalistic mindset that like larger models are better than smaller models. And it turns out among people that are actually training smaller models, this is not true. Like if you have like a model and fine tune it on specific data sets, you can get better performance than like a more general larger model. And so again, you don't learn this like by like reading a textbook. You learn this by like just trying for yourself and being bold and trying to see, well, what if this conventional wisdom is wrong? So I really want to highly recommend you spend more time on GitHub. I used to spend time on Twitter. I don't anymore. I'm on GitHub these days. GitHub's amazing. And GitHub's amazing because you can see like actual systems that people have built that sort of like have all the hidden assumptions that don't exist in a textbook. So I kind of like, but I know people might go to a repo and they'll say you go to something like Python, it's like millions of lines of C code and it's going to be very complicated. So how do you get started? Well, it's actually quite. I have this algorithm that I follow even on new repos that I contribute to. It's basically I look at good first issues that are tagged and I try to solve them. If I can't do that, I'll try running their getting started guide. I can very reliably find bugs, and I'll send the PR. And then I sort of like lurk on their issues and I see what are people complaining about. I build a mental model for the limitations of a library. I'll fix some small bugs, and eventually I'll pick up some bigger features. And this has worked like very reliably for me, even outside of the projects that I contribute to on my job. So in general, like when you're graduating now, you might be like evaluating job offers. And I would highly recommend you sort of, I don't know like if 2x is maybe the right number. It is for me. But if you have like a job that allows you to do open source during your day job, that's kind of like, I think, the ultimate engineering perk, and you should heavily consider it. And the reason being is like, you basically build a portfolio, you build a community, you learn a lot more, and you can get like, that really nice salary, maybe like a bit more of a deferred state, but you'll certainly like learn a lot more in being part of communities. So even then, like, So if you look at like ML science, for example, like one thing I want you to avoid is again like reading the new architecture paper that just dropped saying like something is better. There's a few ideas in machine learning that have really stood the test of time at this point. Like one is windowing, like window detention and convolution. Window detention just recently showed up in Mistral, for example. Residual connections. Optimizer research is just like an absolute mess. Like you can't reproduce anything. So the two optimizers that actually work are atom and gradient descent. And so when something new drops out and you're curious about it, just have like a very quick way of validating whether it actually works. Like don't take the author's word for it, because the author is incentivized to tell you that their technique is state of the art when that may or may not be the case. So one like really useful approach is like what I call like resource constrained ablations. So this is like a fantastic paper I really love called cramming. And what this author tried to do is train a language model on a single GPU in a day. And it's just shocking how many bad ideas this paper sort of highlights. Just like when they're like, well, we tried this, which is conventional wisdom and has like 1,000 citations, doesn't work. We tried this other argument, also doesn't work. So you should sort of really get good at running these fast experiments because, again, most things don't work. Not everything can be state of the art. That's just not possible. So even though however, a lot of architectures nowadays have converged around like transformers. But the architectures aren't changing as much as they used to, but the infrastructure is. So for example, like let's assume that you have a fixed architecture, which is like you want to make a transformer fast, and let's say it's a function f. So given a function f, how do you make it fast? Well, one way is you remove all compute bottlenecks. So if you're interested in compilers and programming languages, this is like one area where you can contribute. You can remove all communication bottlenecks. If you're really good at networking, you want to contribute to projects like DeepSpeed or FSDP, this is like something you can work on. If you're more interested in like low-level stuff and you want to remove things like I/O bottlenecks, you can work on things like flash attention. So pretty much like every sort of core area of computer science has a very foundational compute bottleneck that it's like working on. So you can always like find something depending on what you're good at and what you're interested in. So the last part of my talk is like around like building communities. So my sort of personal credibility here is like I built 2 communities so far. The first one was called like the Robot Overlords. This was a community like centered around like my blogs. Had about 500 people. The second one was a bit more successful. It was like about 1,200 people, where the goal was to build like fine-tune LLMs on a single GPU in a single day. And who knows what my third community is going to be, but this is sort of something I see myself doing for many, many more years to come. So the community 101 tip I have for you is that you need to sort of share bold goals in public, even if you have no idea how to attain them, because others will come in and help you. Like the vision just needs to be sort of interesting and compelling enough. Let's see. So I want to go over like this example, for example, from Deng. So Deng is the mod from Hacker News. He's sort of a benevolent dictator there. And like one thing Deng mentioned is that he's like, well, a lot of times people will complain to Deng with something along the lines of like, how come like Stripe shows up at the front page of Hacker News every time? Like this feels rigged because Stripe was a YC company. And Deng gave like I thought like a very good textbook explanation of communities. He said, well, no, like they're frequently at the front page because their products speak to developers. They have a clear audience in mind. Their blogs are well written. They solve a clear problem. If people ask them questions, they answer, and they answer genuinely without sales jargon. So Stripe is on the front page of Hacker News very frequently because Stripe knows how to interact with communities, and so should you. So my parting thought is this. So this was a picture from the Hugging Face like AI meetup in Paris. It was the largest open source AI meetup in history. It's like a few thousand people were there. And you can see there's this person here while this party is going on who's coding. And I would encourage you to be more like this person. So go to parties, not too many. Like make sure you sort of engage with communities. But like the important thing is that you're building interesting things in public and not that you're just there. So yeah, the TLDR is this. I give this long intro. Really ignore the prophets of doom, especially those that don't practice like what they preach. I would highly recommend you work in open source AI. Be ambitious there. I think there's sort of like still like infinite opportunities here. Be a part of or learn how to create internet communities. Like I think this is sort of for me going to be the future of how education is done, is people teaching each other. And then in terms of like specific skills that you can cultivate, so things like math, programming, systems, will really help you filter out a lot of the noise from the wider community. So yeah, I lost my voice, but thank you. That's it for me.
if we have questions from the audience, there's a mic right there. And then if you have any questions about PyTorch or Meta, please come up afterwards and we will do a one-on-one. Any questions publicly now? You want to just flash right? PyTorch and Meta only? Is that what you're gonna have? Here we go. Public question. Okay, right ahead. And just please make sure the mic is on side. Pressing. Yeah. Oh, just shift it up. Thank you.
So for someone starting out with open source, what Python packages would you recommend getting into? Well, what packages would have a good getting started guide and good first issues?
Okay, yeah. How do I answer this without talking about PyTorch? Okay, yeah. So let's say, like I would say typically projects you're familiar with are just more interesting. So I don't want you to sort of pick up abstract projects that don't solve. So if you happen to use up a package already, then that's like a good start. So let's say Python, right? So you go to the Python repo, and like I said, you notice like it's a couple of millions of lines of C code, and the PRs are like thousands of lines long. And you're like, oh my god, what do I do? Well, it turns out like Python is a project, but Python is also an organization. What I mean by this is there's going to be like their benchmarking suite, their like release infrastructure, their like type annotations. So they have like all of these projects that are like Python adjacent, where it's as high impact for you to contribute to, but the learning curve will be way, way shorter. So yeah, the TLDR is projects to like pick organizations you like, that you feel you want to be a part of those communities in the long term. And then pick the sort of side problems, like do the work that no one else wants to do, because it'll give you more confidence to eventually pick up the harder core problems.
Hello. So wait, can you hear me?
I can hear you.
Okay. So I think you were talking like a bit earlier about how like most of the push for regulation is from like companies which are already in AI and they're just trying to use that to kind of like block everyone else out. Do you think that there could be like any sort of regulation to work almost in like the opposite direction to kind of force them to like communicate with the open source community and maybe like make things more open?
Yeah, so just in case people didn't hear. So the question was around, is there sort of like any helpful like open source regulation that we could have? Okay, so I might get like a very patriotic take here. Like I feel like open source is like very aligned like with American values in general. So like it's sort of like it's open, it's like collaborative, it's a positive something. So for sure, like I think a lot of companies are choosing to help out in open source because they notice there's benefits to doing so, like selfish benefits. Like for example, like if you're Google and you contribute to Kubernetes, that's great because now you can use Kubernetes both internally and other people are improving it for you. And now you're less likely to have this legacy technology that no one maintains internally. So there are selfish incentives for companies to do more open source thing. Whether they should be forced to do so in some capacity, I don't feel like I have a good answer. But I feel like a lot of sort of the smart people are realizing that there's sort of a lot of benefits to being part of these communities. It's very scalable. So I think it's how I'm spending my time. I hope other people spend.
Do you think that there could be like any sort of way we can line up those companies' incentives to do kind of like better things for the community, I guess?
No, like I mean, so I don't personally believe there's how about this? Like I don't want to have like a structure where you sort of force people to contribute to open source. Because there's like a very easy way of doing this, which is like, it's called the throw it over the wall open source. And what that is you produce a project, which is like a bunch of hard together scripts, and you're like, you put it on GitHub, and you're like, oh, it's open source. That's kind of useless actually, because it needs to be maintained. You need to be fixing bugs, you need to be responding to people. So I feel like unless that culture exists at a company already, or they want it to exist, I have a lot of trouble imagining how to force people to be able to.
You made a lot of emphasis on being part of a community and learning from the community, but sometimes I really find the difficult part is finding the community. How do you find a community? It's like, how do I don't sound so silly, but it's like a Reddit forum or it's what it is.
Oh yeah, sure. Yeah, so the question was around like where do you find communities? So in general, like the ones I've enjoyed working on the most were ones that I created. It was more like, like I look at communities, I'm like, okay, well that's cool, but like I really want to do this. Like for example, I'm really passionate about, like I want to figure out like what are the limits of like fine tuning like an LLM on a single GPU all day. And I give it like sort of like a cool name. It sort of is very clear to people what the goal is. And people just like want to join because I'm just saying like, hey, I'm going after this cool thing with or without you sort of thing. And then people want to sort of tag along for the ride. That said, I mean, like there are like lots of excellent ones. Like for example, like on Reddit, there's like the local llama community, which I think is like very good. And then if you just go to that community or the machine learning subreddit on Reddit, you'll find like a couple of big ones like Luther, like New Research. I'm happy to give like a link. If you want to like message me later on Twitter or anything, I can like just send you like a concrete like list if you're interested. But the key thing is like I would say like like it's important to find something that also sort of jives with you. Like you feel like I like these people. I like hanging out here, and that may or may not be the true desire. So I'd say that's like the main thing. Like find people you're interested in hanging out with.
Okay, thank you.
Hi, thanks for speaking.
Yeah.
Physicians have special knowledge. They encourage us to do things that can have a huge impact on our lives. They also have a board that they have to answer to, and they're licensed by the state. AI is becoming very powerful, and some would say, quote, knowledgeable, unquote, but let's just say powerful, and can make suggestions that can greatly impact your life. Do you feel there should be some oversight and some licensing?
So I would say like the general answer feels like a yes. It's just it needs to be very carefully drafted is the issue. And if the sort of side effect of going from this is a powerful technology to only a few companies should be allowed to do it feels to me like the wrong thing. There are, of course, like harmful uses of AI, and I think like there's a few defenses to this, like whether you sort of publicly call people out, you shame them, you find ways of explicitly combating their strategies, like let's say with things like fake news. So yeah, I mean, I would say like I agree with you, but it's more like I think the details really matter, and I feel like the way the details I'm seeing shape up is going to be closer to you're not allowed to buy a GPU sort of thing as an individual, which I don't feel is the approach we want to do.
What I was thinking of was like certain AI products past the testing stage require a license.
Oh, so that's an interesting point. Like you're saying,
as physicians past a testing stage, internship, whatever, require a license.
yeah, I mean, I think that's more compelling. As in, if something has like a large impact on humans, it should have much more scrutiny associated with it. Of course, like this makes tons of sense. I think just the danger. Huh?
Is anybody looking into how that would be done? I take that as basically a no.
I'm not a lawyer, right? Yeah. But like at least not any major efforts I'm thinking of.
Do you know if anyone's advocating for that?
I think so. Like I mean, like when I see people like the former DeepMind guy saying like, well, we should have an intelligent board and I should be on it, sort of thing. Like yes, it feels like maybe it's a question of like the right people with the right incentives. Again, it's more of like the details matter kind of thing. But I think conceptually people aren't like opposed to what you're saying. I think people would be very supportive, even within the ML community.
Hi, I really like your talk. Thanks a lot.
Thank you.
So my question is regarding your like great advice. That you should probably focus on the fundamentals, time-tested ones. So for someone like me from a non-CS background, what would you recommend? To get better at stuff, especially like systems, compilers, programming languages. Yeah. Thank you.
Yeah. So it's sort of like yeah. So let's say, for example, I gave you like a sub-problem, which is make some local LLM run really fast, right? And that's sort of like the base problem. Very quickly, you might sort of use a couple of libraries and you'll get a sort of number and you'll be like, okay, this is great. Once you sort of want to get like a bit of a better number, it gets pretty wild. Like now, like sort of the core knowledge of CS really matters. But the interesting thing about it is that you'll sort of pick things up because you find the problem motivating. So I think especially if you haven't already spent the time learning this stuff, I wouldn't suggest that sort of lock yourself in the closet and read CS fundamentals for 4 years sort of thing. Like that's probably a bad idea. But more like try to find like certain problems that motivate you. And the thing is, like, if your problem is interesting enough, and if you talk about it in a community, you might just get a compiler expert, a volunteer to help you. So you don't have to be good at everything yourself. But like I think sort of at least being good at getting people excited about the problem that you're excited about feels like one of the fastest ways of learning.
First, thank you for the talk. And my first question is, so you talked about the superintelligence at the beginning, and is it something that will inevitably happen in the future, whether it is 100 years later or 200 years later?
Yeah, I mean, like, speculate. So the thing is, like, it's interesting because, as you asked me, like, to speculate within like 100 years in the future, I can't even speculate like a year into the future. Like, I feel like even things like 2 years ago, things like ChatGPT didn't really feel like something like this could be real. So at a high level, like, let's say in 100 years, could we have like superhuman AI take over humanity? Sure, yeah, I think like that's possible. Like in the sense that like it's just very difficult to predict what might happen in such a long time frame. However, like I do think there's sort of like a strong incentive for humans to not want that. So people will be spending time to figure out like along the way, are we close to this? Like, however, like again, and this is sort of like a future argument, right? But like, can you extrapolate that whatever we're doing with GPT-4, 5, 6 will get us to this? No. Like, I'm not convinced that this is what will give us sort of the Matrix style robots.
Okay, and the other one is so you mentioned something about the proof program. So you give a math statement and then a sequence of statements, and it's leading up to the statement that you're trying to prove. But what is the main difficulty in the large language model? Say you give an initial assumption and you leave the middle step blank and just throw out the conclusion and give the proof that this is true or false. So what is the main why can't the machine do that if it knows what the logic rule is and it has all the information?
So just sorry, is the question like, given like a small assumption, like let's say we can give it like a few axioms, like why can't it go solve like let's say math for us?
Right, and what is the main difficulty behind that for the large language model?
So like, at least I mean like conceptually there's no sort of like conceptual reason why that's not possible. My argument is like more practical. Like let's say even today, like with just like a simple code snippets, it might take like a long time to do this. Like one of sort of like the sort of technical problems with LLMs is they don't really have like a good concept of planning. As in like let's say you want to build a complicated proof where you need to realize like, oh, okay, to prove this, there's like these like 5 intermediate lemmas I need to make. and then these 5 intermediate lemmas, let me prove this other intermediate lemma, and then this lemma, let's me prove this other proof. Like this kind of like planning style is not something LLMs have shown any capability of being able to do today. It doesn't mean like it's not possible. It's just it doesn't seem to be possible today.
Okay, thank you.
Hi, thank you for the talk. Talked a lot about contributing to open source and sort of being part of the community and coming up with these like unique ideas and going through sort of new venues. So if you sort of boil it down to the most generalized form, like picking between going to industry or remaining in academia, for example, could you talk about the value of students, or the value to students between these two decisions, or how do you see that in the context of this?
I mean, I can tell you about myself, maybe if that helps. So like when I was a master's student, I made like I think a career mistake, and my first job was like as a PM. I do not recommend you, for example, have a job like a PM. Because you're like effectively like sort of like a junior bureaucrat, and that's not as helpful as a senior bureaucrat. I think senior bureaucrats have some value. So at least for me, like what I realized was that like it sort of like depends like what your needs are. Like as in like if you're sort of like really passionate about like building, like working on research, and you find the process of the PhD interesting, like inherently, not because you need a visa or something like this, then that's great. Like do a PhD. However, like I mean, if your goal is more to like learn and sort of like if you like programming, then I feel like industry is still a better place, but not like all industry. Like I would say like this idea of open source industry is kind of new, and I would highly encourage you to do that. And for any career that you have, I would encourage you to have a career that allows you to have a public profile. It's gonna help you a lot. So I would have that be the driver thing, and if you feel like you can derive more value from academia doing this, and you can work on deeper projects that are gonna have longer term impact, like by all means, like I think a PhD is a great idea. But if you're sort of just doing it because you want to do some research, you can also do some research in industry and do some open source and really enjoy that. And at least that's what I chose to do. I really enjoy it.
Thank you for a very inspiring talk.
Oh, thanks. Yeah.
I'm a computer science major. I also am an education researcher. So my question to you is from the motivation and also outcome perspective, learning outcome or objective of the open source project. Because as we know, students, whether they're undergraduate or master's program that I think most of the students here are in those major, students already have very heavy workload, and also the professors already chosen learning objectives and the practices. So my question to you is that, do you think that, you may have talked about this, I missed the early part of this. My question to you is, first, do you think that students should start as early as possible or after the graduate? Because otherwise, the time to spend on open source may not contributing to the learning objectives. And then secondly, if you think that they should start as early as possible, what would the right balance? Because as an education researcher, what I worry about is that students' time are very valuable. If they dedicate so much time in they're passionate about certain aspect and then to open source, that may negative impact their learning here. So along that line, I wonder, what do you see the top, I'm not an open source engineer myself, I'm just curious that, what do you see the top motivations? Is it more driven by areas that nobody has done and I want to pioneer that, or is it more like I want to really build a community so that I can spend my leisure time outside of my work, of my study? So just curious, thank you.
Yeah, sure. So I'm gonna give like an answer my former grad school advisor once told me. He told me he never has as research assistants A+ students because they never have time for research. So he exclusively gets A- students because they're doing just like enough, they understand the material, but then they also have time for like other things. So at least like my take on this is I think there's like a lot of value in spare time. So maybe professors are working too hard to fill up the curriculum. And I think maybe they should just relax just a bit. And I think the reason for that is because like you can certainly like you can certainly learn like a lot of the fundamentals, but there's like something really inherent about like this like sense of camaraderie that you get. Like you get it, for example, working on a school project sometimes, but not always. Like maybe sometimes you're stuck with someone you don't like, or they're not doing much, and it sucks, right? But like at least like with open source communities, like it's sort of a very self-selected group. Like you're choosing who to work with and what to work on, and that inherently makes you a lot more ambitious. And I don't have like a good answer for how you should manage your time or how soon you should start it. I wish I started it sooner, but you know I wasn't like a very very good student either. So even like with my B's, I wouldn't have like had a lot of time for this. But yeah, I mean like there's something just about like there's something like quite different if like other people care about what you're doing. They're like invested, they want to see you successful, you're all happy when you're building something hard. So yeah, I mean like it's sort of like I think can dial up your ambitions in ways that I haven't typically seen like on my company. So that's why I like it, but I don't have a good answer for how much of your time should be spent doing that.
Could you elaborate on why you think LLMs are bad at talking to each other?
Why do I think LLMs are bad at finding each other? Yeah, so like essentially like if you have like if you sort of take the sort of hot take that LLMs are like engrams on steroids, then if you aggregate two, then you still have like a single engram on steroids. So this is sort of like the very like shallow argument. That said, like I mean like I think what you might be referring to is like things like chain of prompting or self-reflection do improve the outputs of LLMs. And like by all means, like that's great. Like however, it does feel like sort of like as a technology, it feels kind of brittle and like weird to use. But yeah, I mean, again, like the like at least like how I see a lot of the prompting is like I see it as sort of like a useful local optimum, and it's certainly like it's useful, right? And like at least like for coding, I'm telling you, I use it every day. It's just like I just don't see this paradigm surviving for very long as well.
Do you think it would improve creative capacity though?
Okay, so it depends. So I'm not a creative person. Like I can't draw anything. I can tell you at least like from my sister, for example, who's an artist. Like when she looks at like DALL-E outputs, she goes like, "This is awful." Like she's like, "No artist would do this. This sucks." She finds it like offensive and morally reprehensible. And how could they sort of use other people's data without their will? So that's like something I found kind of strange in that like sort of programmers are very glad to have LLMs take over their jobs, but everyone else isn't. And it just might be by virtue of like, you know, like let's say you generated a cool looking lion, right? For diffusion models, there isn't like a clear way of assessing the quality because it looks cool, I guess. But for an LLM generating code, no, you know if it's correct or not because you can have a test case, for example, and you can see if the code compiles. So the problem is inherently better scoped and more defined.
Thank you for the presentation. I have one thing I want to clarify when you talk about OpenAI. You said that the lean startup methodology does not work, but from my point of view, they are very successful and they empower a lot of creators and you know like build stuff quickly. So can you share like, why do you think that lean startup methodology doesn't work?
No, like it works. Like it works to build a successful product. But like I don't think the lean, like if they actually believed that they were creating a super intelligent AI that can take over humanity, I just don't see how the lean startup methodology is the right way to deploy this technology. So my issue with them isn't that I think the lean startup methodology is wrong. It's just it feels that it's at odds with their stated goals. Like they're saying we want to deploy safe AIs, but what they actually care about is deploying it to as many people as possible. That's why I just kind of don't buy the argument.
I have one more question about, like you are the open source starter yourself, right? What methodology do you have when you start an open source project on GitHub?
Yeah, it's very YOLO, I guess. Like, it's so okay, yeah. I mean, the more serious answer would be, like, the way I think of it is like, there's sort of like a lot of like really amazing people that are building like major infrastructure, and not all of them are doing it even as their full-time job. Like, they're just maybe doing it for fun, or maybe it's like a grad school project or something. But for me, the primary motivation is I deeply admire this kind of person, and I just want to hang out with them. And so for me, it's purely like, I just want to meet cool people. And I think that's one of my primary motivations. And yes, I mean, yes, you get to make useful products for customers, et cetera, but I wouldn't say that's my primary personal motivation.
Thank you.
Okay, it looks like we are good to end there, so let's give a final round of applause. And then if you have any one-on-one questions, please go ahead and line up here. And he says he has a lot of time for us, so go ahead.
I just speak with system around now to the your side. Okay, see you here. But I heard this center is not just open source. That center I've it starts at 8 a.m. and at 5 p.m. and they are second. But I just was reading that he rejects his expectations with electrical just he does not see. By the way, yeah, it's both. You are I mean, I don't mind. Exactly. It's like, don't reject it. I think, okay.
You prefer like upstairs or stuff I don't mind. I want to. Don't worry. Yeah, see you. I'll go around. Anyway.
I just needed this okay. I didn't know hug. I this kind of either I and also the size. Monday. Team the yeah, sorry.
Because they put their own the new person, but
Okay, thanks,
yeah, that's